Hello, people. This is Teacher Calvin, and welcome to another episode of Science I Can Do. And with our great tips, I'm sure science you can do too. Today, you're gonna be watching a video conferencing lesson on the topic of a series of questions found in Booklet A set by a renowned school. So sit back, relax, and enjoy the lesson.
Okay, number 11 has the following setup. Okay, 1A is 0 degrees C. Yeah, hello, can you remember? B is like room temperature. That's true. But someone give water. Living things need water, right, to multiply, right? Yeah, no. Suitable temperature will be most ideal, right? Of course, 0 is not like 0 is like frozen to death already, right? Beyond most living things, right? Right? Can C, something that absorb water vapor. But when you absorb water vapor, I got no water. No water, living things don't grow. Yeah. And at 28, with the sealed container, but they already have water vapor inside. Yes or no? All right, based on experiment, which two setup would tap most likely to find mold on the strawberry after a few days? Okay, reverse from back. Give Aaron the chance to score. Come on, 11. Very easy to score, Aaron. Come on, tell me the answer. Huh? Number what? Number 4. Everybody agree with him or not? Yeah, everybody agree with you. Wow, 2 marks in the pocket. That's good. Why we want to keep on doing that? Okay, again. Number 12. Ali took a 10-minute slow walk from his house to a nearby park. Okay, and rested on a bench for 10 minutes before he jogged home at a constant speed. That means no acceleration, I just constant jogging at the same speed. For 20 minutes, he rested on his sofa. Which of the following graph best shows Ali heart rate from the time he left home to the time he rested at home? Okay. Oh, okay. Mr. Aaron, you understand what he's trying to tell you. You see, when you start, he didn't do anything at the start, right? He just started with a slow walk. All right, so let's say his heartbeat was like example for your understanding. That's what Mr. Andrea is trying to tell you. Okay, Mr. Andrea is trying to tell you there is some discrepancy here. Let's see, for example, you start at 80. Yes, you slowly walk. I can stand to 90. Yes, I can understand to 100 when you jog. When you come home, you rested on the sofa, you look at the rested on the sofa. Finally, after resting your sofa, you become 50, 60. Can or not one? Right? You must end up at your starting point, right? Like you never exercise, right? You understand? Where you are at peace with yourself. So do you know why it is not acceptable to be number 2? Your starting heart rate and after your resting should be the same. Agree on that, Aaron? You're starting at 80 when you just started your jog, and after you rested, you fall below. You understand? No? Didn't say you went to sleep. You went to sleep maybe like that. I don't know. You know, hello? Yeah. So Aaron is not number 2. Well, let me explain to you why is number 3. See, the timing must be like each portion must be firstly the 10-minute here and 10-minute must be the same. Get it? And then the 20 minutes must be like the same. Can you see or not? See the intervals firstly must be the same interval. Cannot be one big, one small. The 210 must add it to the size of the 20. I'm looking at a chart like that. Okay? And why is it not number 1? He started from a zombie. He's dead. 0 heartbeat. Can you understand? Yeah? Same here, number 4. You see, he started at the heart and then his heart fell below, like die already, going to beat at 10 beat per second. Even worse. Can you see how? Can you see? So, yeah, it's number 3 in that sense. But you want to really understand, I can talk to you. See, This is for really understand, huh? He took a 10-minute slow walk from his house to a nearby park. So as he started, he walked, his heartbeat increased. You understand? But since his walk is like constant, it reached a peak where his heartbeat stayed normal, because just to walk the normal jog, his heartbeat doesn't need to like increase further, not so strenuous. That's why, like, let's see, okay, from 80, he reached 90. The heart rate at 90 beats per minute can sustain his leisure walk. That means never really vigorous. Okay, you need this amount. I beat at 90. I can supply you all the energy that you need. Do you understand? That's why it started increasing within the 5 minutes. It just remained at 90. No more need to increase, because that beating at 90 beats per minute will be enough to sustain the energy for the walk, the constant slow walk. Do you understand what I'm saying? Okay, that's why after the 10 minutes, he rested on the bench. Then his heartbeat start to drop, because what? Go back to normal lah. That's why I say go back, drop back. It restore back like that. After the 10 minutes, 11 or 12 or 13 minutes for the matter, slow walk can do recovery. See, went back to 80 like his normal rest position. Everyone can you see? Smart now. And then he ran home. You understand? Now the heartbeat must be more than his casual walk. That's why 90 and above. That's why I see. Can you see now? Yes? Okay, so at this stage, you see when he jogged, his heartbeat must be more than the walk. Can you see? That's why it's like 100. Get it, Mr. Aaron? But hey, he said at a constant rate. So there's no need to, like, after you reach the peak, you just maintain the heartbeat that will sustain you, right? It's not that you're forever accelerating, running faster and faster, So you want to maintain the speed of the jog, you have to higher, but at that stage, it's same. I beat 100, I can supply you. The heart says I can supply you energy for your constant run. You're not increasing. That's why it's just steady heartbeat. And then he reached home, he just plumb. So straight away the heartbeat dropped. No need to supply so much energy, but it must return to 80. Can you see the original 80? Can you see not? Cannot drop below the 80. This guy dropped until like 10 like that, crazy, like you want to die like that. The heartbeat very little. Everyone understand why the answer is 3? Yeah? Okay, very good. Andrea, very good. He can identify the heartbeat drop below the normal heartbeat, which is not possible. Yeah? Study the classification chart below. Forms of energy. Wow, this is so easy. Energy are a bent plastic ruler, book on the shelf. All these like potential energy, right? Bent plastic ruler, elastic potential energy. Book on a shelf, gravitational potential energy, right? Bird nesting on a tree, right? Gravitational potential energy, right? On the tree, very high above the ground. Moving hand or second clock is kinetic energy, right? Shouldn't be there. I think energy R is gravitational potential energy. Okay, yes, potential energy, yeah, okay. Energy S, running horse, mad one, right? Must be kinetic energy, and energy S actually I think is kinetic energy. Spinning disc, see, moving things, spinning dice, no, not this, spinning dice. Fruit on a tree branch, not moving. Hey, this guy not supposed to be there. Yes or not? This is meant for kinetic energy. Rotating wheel of car. Okay. There, which of the objects have been incorrectly classified? I think I identify for you. Yes. Well, what is it? So what is it? Mr. Raphael, what is it? The answer is 2. Because this is could be like PE, potential energy. This is kinetic energy, right? So this fruit on a branch is not kinetic energy. This moving things is not potential energy. So they should have been swapped around. Get it or not? Yes? So energy R, shouldn't be there. Incorrectly classified, and fruit on a tree incorrectly classified. Yeah, in the way I discussed with you, which is number 2. Very good. Hey, next one. Mr. Ruben. Ginny used rubber balls of identical materials same material but different mass. To carry out the experiment, she dropped a 20-gram rubber ball from a height of 5 meters. The ball bounced up 3 meters after hitting the ground as shown below. Which one of the following should she use if she wants to bounce the ball higher than 3 meters? What's your answer? Number 2. All right, let's see. Well, she dropped, initially the ball was 20 gram, yes or no? So this is a 20 gram initially ball, yes? All right. And drop from 5 meters, yes or no? So what is the potential energy? Actually, I taught you potential energy formula. Potential energy is based on the mass, the gravity, and the height. Get it? The mass, the gravity, and height. So what is the potential energy here? Well, at first it's 20. Gravity is just 10 on the earth, okay? Standard one, cannot change one, okay? No extremity. So not really taking this into account, but although this actually comes into account, it's like 10, but we don't really care about it now, times the height. What is the height? 5. So the potential energy is like 100, okay? Again? Of course, the gravity is 10 now, okay? You want to include the 10, but it's fixed, okay? 20 mass times 10 gravity, you need this in your secondary 1 times the height. In this case, is what? 1000, okay? Energy, the energy is called joules, okay? Just let you know, okay? Nothing, right? How much energy you burn, how many calories, how many joules, you know, right? Yeah, just the name. All right, so it started with 1000 joules, and it can bounce back to like the potential energy here. So it's less than 1000, could be potential energy based on mass times height times gravity. Yeah. So in order to reach this, let's just say, okay, just give a number, definitely less than my 1000, 700 joules. Isn't it? This is 1000 joules energy to reach here. Mr. Rubin, understand or not? I think you don't know this concept. That's the problem. All right. So if you anybody agree with him, number 2, or anybody got a different answer? Come on. He put number 4. Okay. He put number 4. Mr. Brian put number 4. Anybody want to follow Brian, or everybody follow? Wow, all the hands. Hey, nobody want to follow you, Ruben. Hello, guys. Listen carefully. So to reach this level, you need 1000 joules. If not, you're not going to make it. All right, so it bounced to 700. Yeah, can? Now, if Ruben says he wants the ball to bounce higher than 3 meters, that means go higher. That means it must have more energy, because to reach this level, you need 700 joules. You know? So if you pick number 2, you pick a rubber ball that's 10 mass times 10 gravity times 5 meter, what do you get? 500. Are you going to make it?
No, you're gonna go there.
Not going to make it, seriously. You understand? Not? So the answer is different, number 2. Do you understand? Because you don't even start with enough energy to go to the height, the energy height that is required. Do you understand what I'm saying? Okay. So here, number 4. Let's check Mr. Brian and who? Oh, Raphael. Oh, Raphael. Science is coming back so good. His rubber ball is 50. Yeah? 50. Let's see. 50 is the mass times the gravity, which is 10, times the height. What is the height? 10. What do you start with? You have 5,000 joules. Can you see now? All we need is to reach the 700. Yes? You may have lost a lot in sound, but you definitely have enough energy to make 500 joules. Can you see now? You may lose in sound, you may lose in anything, but it's going to make it in that sense. Can you see now? Because potential energy depends on the mass and the height. This mass, you have enough energy to drop. Because same material is those bouncy material. I'm not saying it's a brick or something like that. It's the same material. Those bouncy material. So the answer is number 4. Get it? That's why I say this is hard. But please remember potential energy. Okay, it's just like this guy lah. Hey, they say, oh, this guy is like step on here, right? He jump on a plank, right? The plank will lift somebody higher, and then the guy jump from here, piang, and then the guy reach this height. How to he make him jump higher? You either lift it higher and use a bigger mass to bash this guy lah. This guy will boom, fly higher, right? You use a lighter ball money aside to hit him to send him higher. You know what I'm trying to say? Yeah, it's that this type of concept. Okay, nah? Yeah. You need a bigger rock, just throw down, boom, then this guy will fly, right? Because you have more potential and to smash down to send him higher. You understand? When you have a smaller ball here, you can try, but I don't think the guy will fly higher. You understand my logic? Okay, yeah?
Thanks for watching. And if you like what you see, do give us a thumbs up, share, and subscribe. And for more great tips like this, be sure to watch Science I Can Do.